Hey Math 7-8, so welcome to this video on the triangle inequality theorem, which is going to go hand in hand with what we just explored through our straw activity earlier today. So you found your way to the video. What you also need to have open on your computer right now is in OneNote, under your Unit 1 tab, there should be a new page called Notes, Triangle Inequality Theorem. So all that you're going to need to do is watch through this short video, follow along in your own OneNote notebook, and you will be good. And there will be some questions at the end of the video for you to answer. So if you remember from our discovery with the straw activity, we determined that the sum, right, or the total of the lengths of any two sides in a triangle must be greater than the length of the third side, right? So you notice that sometimes the three groups of straws would form a triangle, and there were some cases where the three sets of straws would not form a triangle. So what we're going to do is just refresh ourselves really quickly on how we can do this without actually having straws or something in our hands. If we just wanted to try to determine, based on three sets of numbers, if those lengths would create a triangle. So again, the rule says the two smaller lengths must add up to be greater than the third side. So what we're going to need to do is, I always like to circle the two shorter lengths. And our goal is to see if those add up to be bigger than the third side. So if we quickly check 5 plus 10, we know should be greater than 12 if this is going to make a triangle. 5 plus 10 gives us 15, which is greater than 12, so this one would be good. This would form a triangle. All right, we'll get you set up with one more. Let's do the bottom right. So again, I'm going to circle the two shortest sides. We'll check 3 plus 4 should be greater than 10. 3 plus 4 gives us 7, which should be greater than 10. And here's where you can see a red flag, right? 7 is not greater than 10. So those three lengths, 3, 4, and 10, would not form a triangle, right? Those three straws would not create a closed-in polygon, a closed-in triangle. All right, so we're going to have you try the next two here and see if they would form a triangle. All right, so for the set of side lengths on the bottom left, 6, 7, and 8, 6 plus 7 gives us 13, which is definitely greater than 8, so that would form a triangle. And then lastly, 6, 6, and 12. 6 plus 6 equals 12, right? It is not greater than 12. So in other words, that inequality is not true, so those would not form a triangle. All right, so another way that we can apply the triangle inequality theorem is by saying, well, what if we had a triangle with sides 6 and 10, right? 6 units and 10 units long. Could we find the range of possibilities for the measures of the third side, right? Meaning, well, if we know a triangle has side lengths that are 6 and 10, there is a certain range that the third side could be, right? It would be shorter than something or longer than something. So what we're going to need to do is quite simple in order to write our range here. So we have side lengths 10 and 6 is what was given to us. Well, to find the smallest possible side length, you're just going to take the difference of those. 10 minus 6 gives us 4. And similarly, to find the greatest possible side length, you will just take the sum. 10 plus 6 gives us 16. So in order for this to form a triangle, the range of the answers for the third side would be between 4 and 16. And again, you could check those answers with the triangle inequality theorem and verify that they would, anything between 4 and 16 would work. All right, we'll do one final example. 13 and 8, whoops, sorry, that should be a minus. So 13 minus 8 would give us a 5 for the shortest possible side. And then lastly, 13 plus 8 would give us a 21 for the longest possible length. So again, just another way that you could apply the triangle inequality theorem. All right, so we are going to take a couple minutes to try three self-check questions. So for number 1, you are going to find out which of the following sets of sides would make a triangle. So the video is going to pause. You can use any information that you've learned so far to see if you can make your answer. All right, so for check number 1, hopefully you agreed with answer choice C. If you verified, just like we began the video, right, by finding the 2 smallest sides, taking their total, and seeing if it was greater than the third side, you would see that answer choice C was the only set of 3 lengths that would form a triangle. For check number 2, you're going to do something similar and see if we had a triangle with side lengths 15 and 8 units long, which of the following could not be the length of the third side? So see if you can answer this one and we will check. All right, so one of the skills that we learned in this video was we could find the range of possibilities for the length of the third side, right? So we know a triangle has 15 and 18 as 2 of the side lengths. If we subtracted those, the smallest the third side could be is 7. The largest that the third side could be is 23. So answer choice D is the only answer choice that is outside of that range. So 25 could not be used here. It would not form a triangle. All right, and to wrap up our video, 2 side lengths of a triangle measure 13 and 51. Let's do one more little practice. Find the range of possible measures for the third side. All right, so like we practiced finding the range of possibilities for the third side, you take the 2 existing sides that we know, 13 and 51, you take their difference, which gives you 38, you take their sum, which is 64, anywhere between 38 and 64, not including 38 and 64 though, would work for a possible third side. So thank you for watching this video and following along in your OneNote, and we'll see you at the next video.